All right, so good morning or good day to everyone. So let us continue our topic in GA3, Mathematics in Modern World. So we're done with the topic 1.1, measure of central tendency, as well as the measure topic 1.2, the measure of variation. And right now we will be discussing about 1.3, the measure of relative dispersion. So let's start with the coefficient of variation. So coefficient of variation is a type of relative dispersion that expresses the standard deviation as a percentage of mean. And it is summarized by the formula below. CV, that stands for coefficient of variation, is equal to standard deviation over the mean multiplied to 100%. So our denotation for coefficient of variation is CV, while is this one is the standard deviation and this one is the mean kaning naay badly sa ibabaw. All right. So another measure of relative dispersion is a coefficient of quartile deviation, or also known as CQD, or denoted as CQD. So this can be used if the first and third, take note, this is not second, first and third quartiles are known, it can be calculated using the given formula. CQD, or the coefficient of quartile deviation, is equal to Q3, or the third quartile, minus the Q1 all over Q3 plus Q1, and then the product of that one, or the quotient of that one, should be multiplied into 100%. So that would be our CQD. All right. So just take note on the formula: coefficient of quartile deviation, the coefficient of variation, and the third one is another relative or measure of relative dispersion is what we call skewness. Skewness is the measure of the shape of a curve. Even two curves with the same standard deviation and mean may have a very different skewness. It is a measure of the asymmetry of the distribution of a real valued random variable about its mean. The skewness value can be positive or negative or even undefined. A negative skewness, or a negative skew, indicates that the tail of the side, or of on the left side rather, of the probability density function is longer or fatter than the right side, and the hump of a curve is located more on the right regions. Okay, take note on this one. And then on the other hand, a positive skew indicates that the tail on the right side is longer or fatter than the left side, and that the hump of a curve is located more on the left regions. So that is the positive skew. While a zero skew value indicates that the tails on both sides of the mean balance out and is a symmetric distribution. So those are the three types of skewness: the positive skew, the negative skew, and the zero skew. Okay, so in order for us to understand about the skewness more, let's proceed to the next one. So this is the figure of positive skew. So mo ni ang pasabot. And then for the zero skew, this one, where the mean, the median, and mode are in the zero point 0.5 or in the center. And then for the negative skew, so this is the center zero here, or should I say this is the center rather. If this would be the zero and this is the one, the zero point 0.5 is the center. So ingani ang negative skew, naa siya sa tuo ang iyahang hump, while the positive skew, nasa left side ang iyang hump. Okay, so to know the skewness value of a certain data, the mean, median, and standard deviation must be known. Take note, the mean, The median and the standard deviation should be known in order for us to know the skewness of a certain data. Now, skewness can be calculated using the given equation below. Sk, that is the denotation for skewness, is equal to 3 multiplied to the quantity of the mean of the data minus the median of the data all over the standard deviation. So this would be the denotation for the mean. Kaibaw na mo ani. This is the median and this is the standard deviation. And this is the formula of the skewness. All right. So, all right, let's continue. Another part of this topic is what we call kurtosis. Kurtosis is the degree of how peak or how flat a curve of distribution is with respect to the normal distribution curve is defined by its kurtosis. There are three ways to describe the peakness or flatness of a certain distribution curve. The first type of kurtosis is mesokurtic, which is uh which is defined as a distribution whose kurtosis is that of a normal distributed curve or skew equal to zero. So this is mesokurtic. Okay? So this is the first type of kurtosis. Now another type of kurtosis is elliptokurtic, this one, which is the distribution whose curve of distribution is more peaked than that of a normally distributed curve. And lastly, the distribution with flatter curve of distribution than that of a normally distributed curve is called platykortic. So meaning kung normally distributed siya is mesocortic, if mas peak siya compared to mesocortic, or this one is leptocortic, and then if it is flatter than mesocortic, then that is platycortic. So those are the three types of kurtosis. Now, a kurtosis value of 3 indicates the curve of distribution. Okay, a kurtosis value, or rather, a kurtosis value of 3 indicates the curve of distribution is mesocortic. So kung ang kurtosis kay 3, then that is mesocortic. Now, if the kurtosis value is greater than 3, then it is a leptocortic. So kung ang kurtosis gani kay mula pa sa 3, then that is leptocortic. Now, if the kurtosis value is less than 3, then it is platykortic. So, kung gamay sa 3, it's platykortic. The coefficient of kurtosis for ungrouped data can be calculated using the given equation below. Take note, we do have different type of data. We do have ungrouped data and grouped data. So, for the ungrouped data, we're going to use this formula Ku, that is the denotation for kurtosis, equal to the summation of the quantity of the x minus the mean that being powered by 4 all over the n, which is the total number of frequency, multiplied to the standard deviation raised to 4. So that is the formula of kurtosis. Now, if ever kung 3 gani na, then we can call this kurtosis mesocortic. Same goes to kung dako leptocortic, kung gamay platycortic. All right, so we're done with the ungrouped data, and right now we're going to give the formula of grouped data. So the kurtosis can be calculated the formula below. So this is for grouped data. Ku, again, that is the kurtosis, is equal to the summation of f, and the f is the frequency, multiplied to the x, which is the data, minus the mean of the data, that being powered by 4 all over the n, the total number of frequency, multiplied to the standard deviation raised to 4. So this is the denotation. I know you knew it already. This is the mean of the data, the x. This is the class mark per class interval. And then this one is the standard deviation. wait, this one is the median class. Kay naa may nakabutang sa ibabaw. So, this is the standard deviation and this n is the total number of population or the total number of frequency. Now, let's have some example in order for us to understood what we've been discussed. Okay, so example number 1. The data shown are the scores of 30 students in statistics exam. Find the coefficient of variation, the coefficient of quartile deviation, the skewness, and the kurtosis of the given if 9 class intervals shall be used in grouping the data. So we can say that this is grouped data. So we should create a table on this one. We do have 9 class interval and then we're going to, as we've done before, we can say that there are, our class size is 5. But anyway, just do uh, the process what we have discussed before. So let's proceed to the solution. Solving for the coefficient of variation as we say or as we discussed earlier, CV, the coefficient of variation is equal to the standard deviation over the mean of the data. And then after that, the quotient of that one multiplied to 100%. So these are the table nga atong ma-create based on the data given. We do have 9 class intervals, 47, 52, 57, and then this one, 4, 5, 6, 4, 5, 6, 7, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that is correct. We do have 9 class interval based on the given problem. After that, we tally the data, then we can have our frequency, we can have our uh, class mark on this one. So 47 to 51, since 47 up to 51, our class size is 5. So our class mark is in the third from 47, 47, 48, 49. So that is 49. So nakaibaw na mo ani, so no need to discuss on this one about the class mark. And then of course the f of x, we multiplied the frequency and of course the class mark on that class interval, that is 4 times 49, that is 196. And after that one, since we do have our x or the class mark and the mean of this one, we should know the mean of this table. Okay, so absolute value of x minus the mean. So because we do have absolute value here or absolute bar here, ang atong mga answer on this one should be in positive kay naka-absolute value man. Okay, wala yung mag-negative diri nga part. So, just to continue, the I is squared and there is also an f of this one. The absolute value of x minus mean, that being powered by 2. So, atong i-complete ang table so we can get these data here. So the summation of f or the total number of frequency is 30 and the total number of f of x is 2031 or 2031. The total the summation of f of the absolute value of x minus mean that being powered by 2 is 4834.7. So calculating the mean, so what pa man dito no? So in order for us to know the mean on this one, kay nganong nahimo ning 18.7. So the calculating the mean is this one. The mean is equal to the summation of f of x all over n, or the total frequency. And the good thing, ang maayo na panghitabuan is kahibaw na mo unsaon pagkuha sa mean gikan pa sa 2 previous lessons nga ato ang ginadiscuss. So, our mean is 67.7. So, mo na gigamit dire nga part. So, the x is the class mark which is 49. Minusa na to og 67.7. So the answer should be negative unta, but take note there is an absolute value. So the answer is positive 18.7. And then after nga na kanatong gamiton para atong squared, kung atong squared ang 18.7, mahimong 349.69. And then if and only if ato pa jung i-multiply na into the frequency which is 4, 349.69 times the 4, we can have 1398.76. Then just continue filling out the table here, the table there, so we can have the summation of f of the absolute value of x minus mean that being powered by 2. Just excuse kay mo out sa ko. Late unya ko. Ma-post pa ni. Itong just excuse mo di ano ma filter. Apil pa to. Karon nagtabi ko, apil ron. Di na nako edit. Dali ra mo out ra ko. All right, let's continue. Where are we? So here. So our summation of f multiplied to the absolute value of x minus mean that being powered by 2 is 4834.7. Now let's calculate the standard deviation. So standard deviation is equal to the square root of the summation of f multiplied to the quantity of x minus mean that being powered by 2 all over n. So what are we going to do here? Let's just substitute the value of this one. All right. And then, of course, the total frequency or the n. So after substituting this one, we can have a quotient of 12.69. So our standard deviation is 12.69. Now, after getting the standard deviation, we can simply answer the coefficient of variance or variation. So the coefficient of variance is CV equal to the standard deviation over the mean. That will be 12.69 over 67.7. And then the quotient of this one multiplied to 100% is 18.74%. So our coefficient of variance or variation is 18.74. Now in connection to this one, we're done with the coefficient of variance or CV. Let's proceed solving for the coefficient of quartile deviation. In connection, our formula for getting coefficient of quartile deviation is CQD, that is the denotation of coefficient of quartile deviation, equal to Q3, that is third quartile, minus Q1, the first quartile, all over Q3 plus Q1, and then the quotient of this one, we multiply it to 100%. So this would be our first process, calculate the first and the third quartile. So using the same table here, our class interval is just the same. We do have 9 class interval. And then same with our class size. Our class frequency is just the same. And then the next column of this table is less than cumulative frequency, or the CF, or less CF. Now we do have 4. Kay bawa na mo giunsa ni 4 plus 3, then 7. 7 plus 3 is 10. 10 plus 4 is 14. So on and so forth. And we can get 30 less than cumulative frequency in the bottom one. So this would equal into the total number of frequency. Now next, we can, after getting this one, we can solve for the Q1. So for solving the Q1, it is Q1 is equal to K here. Kung nakahinomdom mo na ani sa previous example, or previous topic rather, this is QK equal to K multiplied to N all over. Since this is quartile, so this should be 4. The divisor should be 4. So substitute, since it is 1 multiplied to 30 all over 4, the answer is 7.5. So since Q1 is located at 7.5th element, therefore the Q1 class is 57.261. Kahibaw naman siguro mo no, kung giunsa. So 7 man so ang 7.5 should be here na. Kay it should be mas maayo pa ng uh, let's put it this way. Kung 7 ra ni, kung kini atong himuong uh, quartile 1 class, kuwangan. So since it is 7.5, arita sa 10. Okay? So 57 to 61 is our class interval for the quartile 1. Now, first step is getting the lower boundary of the kth quantile class, or XLB. So our quantile class, or first quartile class, is found on 57 to 61 class. So atong pangitaw ng XLB. As we know, in the lower boundary should be deducted by 0.5. So 57, since it is 57, it would become 56.5. Then after that, we can say that our class size is just 5. And then the type of quantile, or the Q, is, of course, Q is for quartile. So Q is 4. Okay? That is the type of quantile. Next is the class frequency of the kth quantile class, or FQK. So, asa man ka mangita aning frequency of the kth quantile class? Of course, dito sa quantile class, which is 57 to 61. So, by looking at the table, our frequency of the quantile class, atong ipakita, this one, frequency of the quantile class is 3. So, our FQK is equal to 3. Now, the last procedure, or last steps, is getting the less than cumulative frequency before the kth quantile class, or less CFB. The B there is before. So by looking at the table, our less than cumulative frequency before is 7. So kini man no, ang before is 7. So muna. Okay. So we do have the necessary data in order for us to answer the QK, or the quantile, the first quartile. So QK is equal to XLB plus the I, or the class size, multiplied to quantity KN over Q minus the less than CFB all over FQK. So ato ang i-substitute na nato nakuha nga data. It becomes 56.5 plus the class size 5. The K here is 1, kay atong gikuha is the Q1 man. The N here is 30. The Q, of course, since it is quartile, mo ng 4, minus the CFB 7, then all over FQK 3. Then do the math here. Our quartile 1 is 57.33. So we do have our quartile 1. Let's proceed our third quartile. Since Q3 is located at 22.5 element, kini giunsa ni pagkuha, same procedure sa atong gibuhat sa Q1. Okay? It's QK equal to K multiplied to N all over 4. And then our answer would be 22.5 element. So 22.5th element, therefore the Q3 class is 77.80, 77 to 81. So this one, 22.5. So lapas sa 22. So here, 77 to 81. Our FQK for this quartile is 3, and our less CFB or before is 22. So nga na ra. Now let's proceed to our steps. First is getting the lower boundary of the kth quantile class. So since it is 77 for this one, minus 0.5, our XLB is 76.5. Our class size is still, it's 5. Type of quantile still, our Q is 4 because this is quartile. And our class frequency of the kth quantile class, or FQK, as I mentioned earlier, is 3. Ato ipakitag balik. This one, 3. Now, let's proceed to the fifth or the final steps here, the fifth steps. So getting the less than cumulative frequency before of the kth quantile class, or less CFB. Here. So same procedure, just substitute. We do have 76.5 plus 5 multiply to the quantity of 3 times 30 all over 4 minus 22 all over 3. So our Q3 or third quartile is equal to 77.33. So after getting Q1 and Q3, we can answer the CQD right now. Okay, our CQD is equal to Q3 minus Q1 all over Q3 plus Q1. And the quotient of this one should be multiplied into 100%. So we do have 77.33 minus 57.33 all over 77.33 plus 57.33. Our CQD is 14.85%. All right. So we're done with CV, and then we're done also with CQD. Now let's proceed on solving for the skewness of this problem. As we remember, the formula of skewness is SK equal to 3 multiplied to the quantity of the mean minus median all over the standard deviation. Now, we're going to use the same table para same table para continue. So we do have class interval, class frequency, class mark, f of x, less than cumulative frequency. Okay? And then we also do have a summation of f of x here. And of course, the summation of f, or the total number of frequency. Now let's proceed. Calculating the median first, since these are the things that we need to know, the mean and the median. We know about the mean. Let's proceed to the median. Now, for the median, as we use, in order for us to get the median class, use m equal to 30. That is the total number of the frequency over 2. Uh, of course, it will equal to 15. So therefore, a median class is 67 to 71. Let's check. 15 lapas sa 14. So this one, 67.71. Ang atong agdon is si cumulative frequency. Okay, same with basta mangita gayta sa class, median class, class mean. So anita magbase sa cumulative frequency. Now, since we do have the median class 67 to 71, we can say that our XLB is 66.5, our I is 5 still, and less than CFB or the B4 is 14. Let's check. Yes, that is 14. And then our FM, or the frequency of the median class, this one. Frequency of the median class, this one, 5. Okay? That is the frequency of the median class. So ato sang highlightan na atong median class para this is our median class. Okay? All right. Oh, no, no, no. Okay. Now let's proceed. Um, we do have our frequency of the median class. So we can say, or we can use this formula, no? Ato naman yung nahatag, ugwa man gani. So this is the formula of getting the median. Median is equal to, in take note, this is for group data ha. Median is equal to XLB plus the I. So same with this one, okay? And then, of course, we substitute this data here. 66.5 plus 5 multiplied to the quantity of 30 30 over 2 minus 14 the less CFB and all over 5 the FM or the frequency of the median class. We can get 67.5. So we do have our mean. So next we should get our mean. Sorry, we do have our median rather, and after that we should get the mean. So calculating the mean, this is the formula. Mean is equal to the summation of f of x all over the total number of frequency, or 2031 divided by 30. The answer or the quotient is 67.5. So we do have our median and we also have our mean, so we can calculate the skewness of this one. So using the standard deviation calculated while solving for the coefficient of variation, so nakaibaw naman ta after getting coefficient variation that our standard deviation is 12.69 ato nang gamiton. So kining tulo nga nakita ninyo, standard deviation, the mean, the median, those are the three necessary data nga atong gamiton in order for us to get the skewness of the data. So the skewness of the data, again, it's equal to 3 multiplied to the quantity of the mean minus median all over standard deviation. So we're going to substitute everything there. So we do have 3 multiplied to the quantity of 67.7 minus 67.5 all over 12.69. So our skewness is 0.04728. So from the calculated skewness, we can conclude that the curve of distribution of the given data is close to normally distributed curve. Nga naman, duol sa zero. Pero di siya normally distributed. Nalay nakabutang, close to normally distributed kay zero man. Okay? So as we remember, a zero skewed or skew is normally distributed. Okay? So duol-duol ni siya sa normally distributed curve. Okay, so let's proceed. After getting the skewness, then we going to do or to get the kurtosis of this one. So solving for kurtosis, we should use this formula. Kurtosis equal to the summation of f of x minus, or should I say f multiplied to the quantity of the x minus the mean that being powered by 4 all over the total number of frequency multiplied to the standard deviation raised to 4. So para sa yon, ang atong buhaton is to continue filling out this table here. So taman sa raised to 4. So raised to 2, raised to 2. Of course, then if we're going to raise it to 4, then it will become 12,000. I'm sorry, it's 122,283.1. You do the process lang. We continue the process here, and then we can have the summation of f of the f multiplied to the absolute value of x minus mean that being powered by 4 is 1560336 or 1,560,336. So after getting the data that we are going to use in answering the kurtosis, then we going to use, or should I say, we're going to use the same standard deviation in the previous lesson. I mean previous topic. Okay, so kurtosis is equal to this is the formula I mentioned earlier. So what are we going to do is just substitute. So 1,560,336 all over, I mean over 30 multiplied to 12.69 that being powered by 4. So our kurtosis is 2.00628. So from the calculated kurtosis, we can conclude that the curve of distribution of the given data is aplatykurtic. since its kurtosis value is less than 3. So, hapit siya ma-normally distributed in a sense of skewed, pero ang ato ang kurtosis is somehow it's flat. Okay? Flat siya. So, that's why it's platykortic. Kay less than 3 ang atong kurtosis. Okay. Now, let's proceed on the second example. Kay basing naglibog pa mo sa first example. So, in the exam given in the top 32, so the following scores were obtained. Find the coefficient of variance, coefficient quartile deviation, skewness, and kurtosis of the given data if 9-class interval shall be used in grouping the data. So, pila ni 32 students. Okay, 32. Okay, sakto 32. Ato sa kuno i-check ning diri kay basig naarap ko nabantayan sa iyo ato san tanaw. 5, 10, 15, 20, 20, 30. Sakto, sakto. Okay. Atong ipon, 2, 4, 6, 8, 8, 16, 16 times 2, 30. Sakto. Okay. So, natay 32 ka estudyante and still, 9 class interval gyapon ang gisulti sa uh, ato ang problem. So, solving for the coefficient of variation, okay, CV equal to standard deviation over the mean and then multiplied into 100%. So this would be our table. Okay. So 29, 30, 31, 32, 33. So we can say that still our class size is 5. So kung naglibog mo nga anong 5 ang atong class size, go back to the previous sa measure of central tendency and you going to know kung yun sa pagkuha ang ginatawag na class size. Now, it's 2, 4, 6, 8, 9. 2, 4, 6, 8, 8 talaga eh. It should be 9 class interval as is stated here. So, let's check. It's 29 ang pinakagamay. Dayon, ang pinakadako is 68 or around there, 65. 65. Okay na. 64 to 68. So 2, 4, 6, 8. Okay. So as stipulated, wa na siguro gibutang diri ang 69 to 73. 69 to 73 kay wala may frequency nga nakabutang. So if that would be the case, pero if ingana gani ang mahitabo walay frequency, still ibutang lang gihapon. But here wa man gibutang, okay? Kung tahay mahitabo nga walay frequency o nya naka-indicate dito nga 9 gihapon ka class interval, ibutang lang gihapon. Okay? So frequency, these are the frequencies. So the total number of frequencies is 32. The class mark hibaw na mo giunsa 31, then this one 66. Suppose napay sumpay diri, it should be 69 to 73. Anya mahimo siyang 71. Okay? And then for the f of x, same. Okay, the calculating mean. So mean is same formula. Summation of f of x over n, 1507, this one, over 32, this one, and then equal to 47.09. And after that, calculating the standard deviation using this formula. Okay, and then we're going to input or substitute these data here. 4286.719 all over 32. Ato nang yung square root katong akong ginahisgutan. So it's 11.57. Our standard deviation of this example is 11.57. Now, therefore, the coefficient of variance or CV is 24.57. And then after that, let's solve for the coefficient of quartile deviation. So same scenario, we can't answer this one until we get third quartile and of course the first quartile. So what are we going to do? Let's find the first quartile and then the third quartile as well. So using the same table, And then just continue putting up in the next column the less than cumulative frequency. And then, of course, uh, get the Q1. So it is located at the eighth element. Therefore, the Q1 class is 34.38. So 8, so here, 34 to 38. Muna to ang Q1 class. Now, steps, there are 5 steps. LB, XLB is 33.5. Class size still 5. Type of quantile is 4 because this is quartile. Class frequency or the FQK is 5. Let us check. 5 ba? Yes, it is 5. Now, let's proceed for the less than cumulative frequency before or less CFB. Less CFB is equal to 5. Tanaw na to kung 5 agad. So this one, all right. The less CFB is 5. Okay. Now, substitute everything there so we can get 36.5. Next, solving for Q3. Same scenario, same formula. So our third quartile class is 22.5th element. Therefore, the Q3 class is 54 to 58. So after that, XLB, that is 53.5. And then the class size still 5. The quartile is still 4. And our FQK on this one, the frequency of the kth quantile class, that is 4. Okay, so that is for this one. 54.54 to 58 man. Okay. Now, let's proceed to the FQK. Oh no, I mean the less CFB. The less CFB is 20. Check na to. Okay, 20. This one. Okay. Now, after getting the less CFB, then we can say the third quartile is 58.5. So after getting the third quartile, we can answer the CQD. Oh, that would be exactly 23.16%. So that is our CQD. Okay, next is solving for skewness. Solving for skewness is 3 multiplied to the mean minus median all over standard deviation. Using the same formula, we continue the table by putting out the less CFB and of course the f of x and the class mark. So calculating the median first, same scenario, m equal to 32 over 2 in order for us to get the median class. 16 is the median class, the m. Therefore, the median class is 44 to 48. Atong i-check, 16, so wala pa sa 14, so kini. Okay, so 44 to 48. Now, our less CFB is 14. Okay, that is correct. Now, our FM or frequency of the median class is 4. Yes, that's correct. And then, okay. What's everything here? Or should I say we substitute everything here? And we can say the median is 46. Okay, let's continue by calculating the mean using the same formula. The mean is 47.09. So using the standard deviation calculated while solving for the coefficient of variation, that is 11.57, the standard or the skewness is equal to 0.2826. From the calculated skewed, we can conclude that the curve of distribution of the given data is close to normally distributed curve. Next is solving for kurtosis. So in solving for the kurtosis, nagkinahanglan ta ingani kinalasan nato nga data here. So that's why it's very important to continue filling in the table in our data. Okay, and the next, using the calculated standard deviation, the previous part, our standard deviation is 11.57. Kurtosis, substitute na to using the same formula. It's 922,295.1 all over or over 32 multiplied to 11.57 of being powered by 4. Kurtosis will become 1.6084. So from the calculated kurtosis, we can conclude that the curve distribution of the given data is a platykurtic since its kurtosis value is less than 3. So same with the earlier example, our kurtosis is platykurtic. All right, so that would be the end of our 1.3. Okay. Okay, that's the end for our measure of relative dispersion. So, napanay sumpay, so just chill or just relax. Bye for now.